graph represents the height above the ground of one of the cars on a Ferris wheel. Determine the height of the hub or center of the Ferris wheel. Now, the height of the hub, that sounds like the D value to me. Well, if I'm looking at a D value, I'm taking the average of the minimum and the maximum. So I just add the min and the max together and divide by 2. So that gives me 10 meters. Okay, then we say determine the radius of the Ferris wheel. Well, we talked about the context of all these guys. The radius actually is your A value. So to get your A value, you would take your the maximum minus the minimum, so you get the full distance there, and then divide that by 2. Or if you want to just draw in your D value and count how far up you have to go, that's perfectly fine as well. Okay, just make sure you're communicating what you're doing. Okay, then state the period of the Ferris wheel. Well, I can actually see that right off the graph. The period's 100 seconds because I start at this minimum here, and then I go to this minimum here. So total period would be 100 seconds. And now it asks me to create an equation. So I know the A was the radius, and I've already established that, that's 5. B, well, I know my period is 100 seconds, so that'd be 2 pi over 100, which would be pi over 50. The D value we also established was 10. Now, to do a C value, if we're looking at sine, remember we said that if we're starting at the minimum here, the phase shift for sine is actually going to be 1/4 of a period. So if my period's 100 seconds, the phase shift's going to be 25. And then for cosine, if I'm using a positive cosine, it'd be half the period. So my phase shift would be 50. So then those two equations would look like this. And then again, is there a simpler version? Yeah, we could do the reflective cosine, which is -9 cos of pi over 50 t plus 10.